It is the 4th of December in 2020. Inside a clean room laboratory in Veldhoven, Netherlands, a robotic arm lifts a 50-ton assembly matrix. It is part of an extreme ultraviolet lithography machine. An engineer notices that a local network terminal is transmitting an unexplained outbound data stream to an external server. This is the story of how the world's most critical industrial secret was systematically targeted and copied. The machine inside the clean room is the only tool on Earth capable of printing the next generation of microchips. It is manufactured by a single company, ASML. The company is located in a quiet suburb of Veldhoven, but it acts as the structural linchpin of global technology. Without these machines, production lines for high-end microprocessors across the globe grind to a halt. The technology relies on mirrors so flat that if expanded to the size of the United States, the tallest bump would be less than 1 millimeter high. Controlling this technology provides total dominance over the global supply of silicon. A single machine contains over 100,000 discrete components. It costs upwards of $150 million. Shipping one unit requires 3 Boeing 747 cargo planes and several heavily guarded transport convoys. Because the technical hurdles are immense, no competitor has successfully replicated the mechanism through legitimate engineering. But where standard industrial development fails, corporate intelligence operations begin. The threat did not materialize overnight. For years, the security protocols at high-tech manufacturers have focused heavily on external network perimeters. Firewalls are updated hourly. Multi-factor authentication is mandatory for every employee. But these digital fortresses contain a single structural vulnerability. They rely on the absolute compliance of the individuals who hold the keys. In 2018, an elite group of engineers within ASML software division began interacting with an external entity. The entity was a competitor named XTAL, a Silicon Valley startup funded by prominent Chinese technology consortia. The strategy was precise. XTAL did not attempt to breach the network from the outside. Instead, they began targeting specific individuals with access to proprietary source code. They offered massive financial incentives, often exceeding standard corporate salaries by a factor of 4. The mechanism of the theft was highly controlled. Over several months, compromised employees began downloading massive batches of software source code, technical blueprints, and optimization scripts. They did not use corporate email networks to exfiltrate the data. Instead, they transferred the files onto physical storage drives during late-night shifts when tracking was minimal. The data included crucial mask optimization algorithms that allow the lithography machines to project circuitry with nanoscale precision. When internal audits finally flagged the unusual data transfers, the damage was already done. ASML initiated massive legal proceedings in California, eventually winning an $845 million default judgment against XTAL. The startup declared bankruptcy shortly after. The legal victory appeared absolute, but corporate entities are easily dissolved and recreated. The software code and engineering blueprints had already crossed the Pacific. The implications of the theft immediately reverberated through international intelligence communities. The stolen data was not utilized by a small startup. It was absorbed into the state-backed research infrastructure of competing geopolitical blocs. Within months of XTAL's bankruptcies, new lithography development programs emerged under different names, utilizing identical technical approaches to bypass decades of research and development. The global race for silicon supremacy is not fought with traditional military hardware. It is fought in clean rooms, through encrypted databases, and in corporate boardrooms. The infrastructure required to manufacture advanced microchips remains highly concentrated, but the barrier to entry is dropping. The stolen algorithms allow competitors to skip decades of costly trial and error, compressing a 30-year engineering timeline into less than 5. As security teams globally scramble to harden their internal networks against insider threats, the targeted nature of the Veldhoven breach has rewritten the rules of corporate espionage. The legal systems designed to protect intellectual property are structurally incapable of stopping data that has already been integrated into foreign state apparatuses. The technology cannot be uncopied. The Veldhoven cleanroom remains functional, and newer, more complex machines are currently being assembled for international shipping. But investigators tracking the digital signatures of the stolen source code have recently detected identical data packets emerging from a newly constructed, state-funded fabrication plant in Wuhan.